We're continuing with the AP AB Fall Exam Multiple Choice Packet Review. We're looking at problems 16 through 21. So 16 says we have a function that's provided here that exists for every value except at 0, but that point is being filled in by k. And it's saying that the function is continuous at x equals 0, then k must be what? So we're trying to figure out what the k value is that will allow this function to be continuous all the way throughout. So we're going to step through continuity conditions. So the point in question, the x value in question is 0. So the point f of 0 is equal to k, so that's what we're trying to find, condition 1. Second condition is what the limit is, right? Find the limit. So limit as x approaches 0. Now we know that the graph is going to exist on both sides of 0 within the same function. So if we can find a limit as x approaches 0 of this expression, then we can find out where the potential target for k is. So first thing we do with evaluating limits is we plug in the x value. We get 0 minus 0 over 0, which is 0 over 0. And so we can, in determinant form, we have to continue to do work with this expression. So we can factor out the x, and x times x minus 1 over 2x. The x's cancel out, and we're left with x minus 1 over 2. Reevaluate the limit, we get 0 minus 1, which is negative 1 over 2. So the limit exists at negative 1/2. So in order for the third condition to pass, the third condition is asking if the first two conditions are equal to each other. So if we allow k to be negative 1/2, then the third condition will pass because the point is being filled in by this order pair 0, negative 1/2. Okay, so the answer is B, negative 1/2. 17, we have a function that exists everywhere except at 1 and 2. However, we do see order pairs for those points. Then it's saying the function is continuous at all real numbers, or is it going to be at a variety of different x values. So we're talking about continuity here, so we're going to go through continuity conditions. However, we need to go through continuity conditions for two separate x values. One's for x equals 1 and one's for x equals 2. So at x equals 1, we know f of 1 equals negative 3, so that's the first condition. Second condition, the limit as x approaches 1 for this function here. So limit as x approaches 1, we can factor the denominator because initially we get 0 over 0. Factor the denominator, we see the x minus 1 cancels out, so we're left with 3x over x minus 1. Reevaluate the limit, plug in 1 in for x, we get 3 over 1 minus 2, which is 3 over negative 1, which is negative 3. Okay, so the third condition is checking to see if the first two agree with each other. Order pair is negative 3, limit is negative 3, so therefore our condition pass. We know the function is going to be continuous at x equals 1. Okay, so now on to x equals 2. F of 2 equals 4. Okay, next we want to determine what the limit is as x approaches 2 for this function. So limit as x approaches 2, again the x minus 1 cancels out, but when we plug in 2, we're going to get 6 over 2 minus 2, or 6 over 0. 6 over 0, the limit doesn't exist, means that the function is not continuous at x equals 2. And so we know that this function is continuous everywhere except at x equals 2, and it's even continuous at x equals 1 because this potential hole is being filled in by this point. Okay, so the only place where this function is not continuous is at x equals 2. Okay, number 18, we're given a function here, numerator over denominator. We want to find dy over dx. So looks like we have to go through quotient rule. But quotient rule, look at the denominator though. We also have to think about going through chain rule. So chain rule, denominator, we have an outside portion and inside portion. Okay, outside and inside the parentheses. So go through quotient rule. F prime g minus fg prime. So f prime, x becomes 1, f prime times g minus f, that's x. G prime requires us to have to go through chain rule, bring down the 1/2, keep the parentheses, subtract 1 from the exponent. 1/2 minus 1 is negative 1/2. Multiply it by the inside function's derivative. 1 goes 0, negative x squared goes to negative 2x. Denominator squared, okay? And then it's just a matter of trying to clean this up. This is essentially square root of 1 minus x squared. The 2's cancel out between numerator and denominator. The negative come out as positive. X and x becomes x squared. And then the 1 minus x squared to the negative 1/2, we have to bring that down to the denominator within this numerator portion. Okay, all over denominator squared. The 1/2 and 2 will cancel out, leaves us with 1 minus x squared. Now, this expression, we have a complex fraction. So the way we undo the complex fraction is we identify the portion that's causing the complex fraction and multiply numerator and denominator by that value, by that term. Essentially, we're redistributing this to the rest of the expression so we can get rid of this part here. But we're multiplying by 1, so we're not changing anything within the expression. So distribute the square root through. Square root times square root will just be the term inside the square root, so 1 minus x squared. Numerator and denominator are matching, so they cancel out, leaving us with plus x squared. Denominator, okay, this is 1 minus x squared to the first power. This is 1 minus x squared to the 1/2. We're multiplying like bases, so when we do that, we add exponents. 1 plus 1/2 is 3/2. Negative x squared and x squared will cancel out, leaving us with just 1. So 1 over 1 minus x squared to the 3/2 does not match any of these answer choices, so it's going to be E. Okay. Number 19, cosine of x squared, find y prime. X squared, only the x is squared, okay, so it's within this u value. So the derivative for cosine of u is negative sine of u times u prime. X squared becomes 2x. So we just bring that out in front. Negative 2x sine x squared. Answer choice D. Okay, number 20, sine squared 3x plus cosine squared 3x, find dy dx. Now, if we can recognize this as simply the trig identity, Pythagorean identity, sine squared plus cosine squared equals 1, then we can save a little bit of time because this is essentially 1. And if this is equal to 1, then the derivative of 1 will simply be 0. Okay. But if you didn't see that and you just went through chain rule, you can still get to the answer. So let's go through that step as well. So sine 3x raised to the second power, cosine 3x raised to the second power. Okay. Whenever I see that this exponent affecting the whole function, I want to write it outside the bracket so I can keep track of the different parts of this nested chain rule. So let's take care of the bracket's derivative first. Bring down the 2, keep the bracket, subtract 1 from the exponent, multiply now with the inside function's derivative. Sine of u becomes cosine of u times u prime. 3x becomes 3. And now we move on to the second expression, second term. Bracket square, the derivative of bracket squared is going to be 2 bracket to the first power. Multiply by the inside function's derivative. Cosine of u becomes negative sine of u. And then finally the u prime is times 3. Okay. Bring all the coefficients out in front. 2 times 3 becomes 6 sine 3x cosine 3x. Bring the 3, the negative 1, and the 2 out in front becomes negative 6 sine 3x cosine 3x. And then these are like terms. They just have positive 6 and negative 6, so that cancels out to be 0. We get the same answer either way. Number 21, cosine of squared x. So this squared is just like number 20 in the sense that it's outside the bracket. So we just find the derivative, bring down the 2, keep what's inside the bracket, subtract 1 from the exponent. Now multiply by the inside function's derivative. Cosine becomes negative sine of u, and then u prime is 1, so it doesn't change anything. Bring the negative in front, negative 2 sine x cosine x, but it doesn't match any of the answer choices, so we look to see what else we can do. This is a double angle that we can write as sine of 2x. Negative still stays, so 2 sine x cosine x becomes sine of 2x, and negative stays, so that matches answer choice C.